All right, so for today, what we did is we're looking at more stuff with functions, just looking at more characteristics. So today we kind of went over a little bit of vocab, and then we're going to look at what's called Extrema. Okay, you can find this notes packet on Schoology, so you can print it off, or you can just write these notes, whatever's easiest for you. All right, so a couple words, a couple of vocab words. So degree. The degree of a function is going to be whatever the highest exponent is. So for example, if we have this function here, these are called terms. So terms are separated by adding and subtracting. So if I look at this, my highest exponent is 2. So I would say the degree of this equation is 2, or the degree of this function is 2. Leading coefficient. So a coefficient is this big number, like this 3 or this 2, in front of the variable. So when we say the leading coefficient, we're meaning the number that's with the highest exponent. So in this case, the leading coefficient would be 3. So you can see why it's important to write your functions with your descending order of your exponents, because it makes finding the degree and the leading coefficient a lot easier. And then the fundamental theorem, or I'm sorry, the number of zeros goes back to the fundamental theorem of algebra. Right? So it told us that whatever the degree or whatever the highest exponent of the function is, that's going to be how many zeros or how many solutions that problem has. So remember when we did quadratics, this is squared, so we always had 2 solutions, right? Because it's to the degree of 2. Okay? All right, so here are just some examples here. So if it's just a number, we don't have degree, leading coefficient, or zeros, right? Because we got to have an actual function or an equation. All right, so then we have 4x minus 9. So the degree, remember that this actually has to the first power. So this degree would be 1. And then the leading coefficient, the 4, is with that particular variable. And then the number of zeros would just be 1. So think this is a linear equation, right? This is just 4x minus 9 equals 23. And you'd only have one answer, okay? All right, for this one, my degree is 4, and then my leading coefficient, the number out front with that 4, is a 2, and then the max number of zeros there is going to be 4. Here, my degree is 2, leading coefficient is 5, and again, your degree and the number of zeros are going to match, so both of those were 2. Okay, so hopefully you get the gist of that. You can pause this part of the video and you can write these down if you want, or just take a look at them. All right, so now what we're going to get into is called extrema. Okay, so extrema are like the extremes of the graph. So we're going to be looking at graphs for this. We have 4 different types of extrema. We have absolute min, relative min, absolute min, or I'm sorry, relative, I'm sorry, let's try again. Absolute max, relative max, absolute min, and relative min. Okay, so you can think that absolute max and absolute min are going to be the same, only one's the highest point and one's the lowest point, and then relative max and min, okay? All right, so an example of our absolute maximum is this right here. So if we had this graph right here, this is the absolute highest point no matter what. Even if this graph were to continue going down forever and ever, this is the absolute highest point forever and ever, no matter how big I make my graph, okay? So here's the definition for that. Again, feel free to pause the video at any time to write down whatever you need to write down. So a point where the function obtains its greatest possible value. So this is its greatest possible value, even if the graph went on forever. All right, so then let's jump down to, excuse me. Let's jump down to absolute minimum, okay? So with absolute minimum, it's the same sort of thing. It's just this is the absolute lowest point on the graph ever, right? So it could also look like this, right? This is the lowest point on this graph. So a point where the function obtains its least possible value. All right, something else to notice is that with absolutes, whether it's max or min, so with absolutes, right? The ends of your graph either both go up or both go down. It doesn't matter how many twists and turns there are. right? It could have all these twists and turns and all sorts of things, but as long as both arrows go up or both arrows go down, then you're going to have an absolute max or min, okay? But that's the only time you're going to have the absolute, is if both ends of the graph are going in the same direction. All right, so then relative. So relative meaning compared to. So relative to the points around it, or compared to the points around it, this is a high point. However, you can see on another part of the graph that this is higher than this point here. So this is just saying in this little area, that's a high point, but it is not the highest point of the whole entire graph. So just compared to where it is a high point. So a point higher than the points on either side of it. Okay, so it's just that area. So this is a relative max. Notice that this arrow goes up and this arrow goes down. So that means if I extended this, this would keep going forever and ever. So it keeps getting higher and higher. So the maximum, there is no maximum because it goes on for infinity. All right, and then just again, the opposite there for relative minimum. Okay, it's a point lower than the points on either side of it. So you can see again, arrows are going in different directions, but this is our relative min because compared to the points around it, it is the lowest point. Again, here's a relative min. Compared to the points around it, this is the low point. Okay, so relative mins, you can have multiple relative minimums, multiple relative maxes on a graph, or maybe neither. So it just kind of depends on what the graph looks like. All right, so when we're talking about extrema, okay, so extremas, so the maximums and minimums, they are going to occur at the turns of the graph. Okay, so if the graph turns, then we should have an extrema there. Okay, so at the turns of the graph. So for example, if I have a straight line, does this line turn at all? No, it doesn't. It continues to go up forever and continues to go down forever. It never switches direction. So for this would have no extrema at all. Okay, so straight lines don't have extrema. So then here, we've kind of looked at this. This has one turn, right? We're going down, 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 down. We get to a point and then suddenly it turns and now we're going up. So this is going to have one extrema because it has one turn. Okay, this will have one extrema because it has one turn. All right, so then you can start to see, right, I have here's a turn, here's a turn. So this was going down, then it turns and goes up, then it turns and goes down. So this has two turns, so guess how many extrema it has? You're right, two extrema. Okay, two extrema. So then 1, 2, 3, right? So 1, 2, 3. So now we're going to have 3 extrema. Okay, and that's going to continue on. So however many turns you have, that's how many extrema you're going to have. Okay, so that's kind of helpful to make sure that you get all of your extrema. All right, so let me show you a couple examples. So on the back of this packet. Okay, so if we're looking at just number 1 here. So we can see here's a turn, here's a turn. So I know that I have to mark both of these. So this is, compared to the points around it, this is a low point. But notice if I go across here, this part of my graph is going to keep on going down forever and ever and ever. So it's going to keep getting lower. So this isn't the most or the least or lowest point of the graph, but it is, compared to that area, it is a low point. Same thing here. This arrow right here tells us the graph keeps going up. So eventually this does get higher and higher than this point. So this is just a relative max. Here, this only has one turn, so we know it's here. And because it just has one turn, it never goes lower than that point. That's our absolute minimum. All right, and then here on this, we have 1, 2, 3, 4, 5 different extrema. Okay, I notice that both arrows are pointing down. So remember we said if the arrows are going in the same direction, then we have some sort of absolute. They're both pointing down, so I'm going to have an absolute max. So then I look at my 3 tall points or high points. This is the highest of them all, so this is my absolute max. Then that makes these two just relative max. So that's a relative max and that's a relative max. and then makes both of these relative minimums because they're low points. Okay? So here we have 1, 2, 3 turns, so we have 3 extrema. Okay? I think this one is meant to be slightly lower than this one, so this is going to be absolute min, and this is going to be a relative min, and this is your relative max. Okay? This one has no turns, so again, that does not have any extrema. Okay? Looking at number 11, just real quick. So notice this, so that both arrows go up. We have 1, 2, 3 extrema. Notice that this one and this one, they're both the lowest point because they're at the same level. So then we say both of these are going to be our absolute minimum. Okay? So when things are at the same level, then we can call them both absolute. Otherwise, you're just going to have one. And then this is a relative max. All right? So go ahead and get this worksheet and try a couple of these, see how you do on it, and then talk to Ms. Carlock, and she can show you what else you need to do. All right, thanks, guys.